Alright, let's go to the next room, which is AI ML security threats. It seems like a very basic kind of a room and more informational, like an hour needed to read the documents and stuff. So let's go ahead together and review what's written inside. So the world is changing. Industries are coming to terms with the reality of how we'll be affected by AI, and cybersecurity is no different. It should come as no surprise that AI is at the heart of many discussions in the cybersecurity industry. A lot of ongoing research is being done to answer the questions so many have at this point of time. This room aims to answer these questions. What is AI ML engineering? What is machine learning? What is artificial intelligence? How can it be used in our industry? How will it affect my role? How is AI being leveraged by attackers? This is like a framework of the room, kind of theoretical parts. So this room aims to ease you into the world of AI so that you can leave with a better understanding of how the technology works and its implications for the industry and the world as a whole. So learning prerequisites, so understanding artificial intelligence, understanding machine learning. You're not aware of, for example, Turing machine. That's not a big case because you're not studying the history of these topics. They're all interrelated. Some of them are computational, some of them are insight problems, some of them are computational problems, past problems like computer science, software engineering, these kind of topics. So these topics are interrelated, but the basic understanding make you understand more. The whole code, architecture, structure, the abstractions, and any kind of layer that you want to add to your software, to your understanding of this security problem. Task 2, the building blocks of AI. We must empower our cybersecurity workforce to combat AI security threats. Knowledge is power, like passive reconnaissance. So we begin by arming you with the foundational knowledge of AI and ML. Let's start by discussing how we define artificial intelligence refers to a machine or computer that is able to carry out tasks that would otherwise require human reasoning, comprehension, problem solving, creativity. So back in the days, for example, in the gaming industry, and even like the first years, like 70 years, 50 years ago, nobody thought like AI would be next revolution after like many initiatives. They thought that AI lacks creativity. They thought that it can do computational tasks, but in inside problem, it's a different kind of a learning for the system. It's a different kind of a methodology. So these kind of basic rules make you think more harder and more deeper into the concepts of machine learning, which is really wide, which is really complicated in some ways. The mathematics behind that is really complicated. It can be challenging and intimidating. Let's go to machine learning and see what's happening. The next significant advancement in the development of AI came with the emergence of machine learning. So machine learning algorithm, it's more robust, it's more perfect than old methods of AI. They've been a bunch. So ML is a subfield of AI that refers to a computer's ability to learn from data without being given instructions and is comparable to how the human brain learns. So it's comparable, but there are differences. Over time, with more data and time, these algorithms will get better at accuracy and decision. Obviously, they're doing a lot of trial and tribulations, try and catch, and they learn from that. Obviously, it grows, it improves. So ML follows a structured life cycle to ensure the reliable development and deployments of models. This process begins with defining the problem, such as determining whether an email is a spam. Here we have some analogy. So it's about email. Prevent that from detecting. It could be like a spam or not. So this is kind of like an analogy here. And next, data is collected, cleaned, and prepared through feature engineering. ensuring meaningful patterns are extracted while avoiding overfitting when a model's familiarity with the training data causes a failure to make generalizations on unseen raw data. So the model is then trained using a selected algorithm followed by evaluation and tuning to optimize performance. Once refined, the model is deployed into a production environment for real-world use, such as classifying emails in real time. However, the lifecycle doesn't end there. Ongoing monitoring ensures the model maintains accuracy over time, triggering retraining when needed. Since models require continuous improvement, the machine learning lifecycle remains an iterative process. So it's kind of like an automation. It has a cycle, it goes through that, iterative. Let's read that. This is a deployment. This is like when it starts feature engineering, when it talks a model evaluation and training, that it goes through model deployment, so it gets deployed, then it's monitored if it's going right, and then we define a problem. So when we detected a problem, we define a problem, we investigate the problem, then we collect some data. So knowledge is power, we know that. Algorithm selection plus model. ML algorithms are the mathematical methods used to learn patterns from data, while ML models are the trained outputs derived from these algorithms. These algorithms consist of three key components: a decision process, which makes predictions or classifications based on input data, an error function which evaluates performance and provides feedback, and a model optimization process which fine-tunes the algorithm to minimize errors and improve accuracy. It says basically we have an error function, we have a machine learning, we have a decision making. ML algorithms fall into four main categories: supervised, unsupervised, semi-supervised, and reinforcement learning. So supervised learning is, what is this? Relies on labeled data to train model, classifications or regression tasks, predicting house prices. Then we have unsupervised learning, on the other hand, works with unlabeled data to discover hidden patterns, often using clustering methods like association, dimensionality, reduction techniques, and semi-supervised learning combines elements of both, using a small portion of labeled data to guide the learning process. Finally, reinforcement learning mimics human learning by rewarding correct decision and penalizing mistakes, allowing an agent to refine its actions over time to achieve the best outcome. Here is like a wide topic. It's a branch of computer science, like a data science, ML, and AI. It's a really comprehensive topic, and it just like stems from that to understand what it is, like just the building blocks, the foundation of this theory. So here, another classic academic approach is like to know about the neural networks and deep learning. So if you recall, the main objective of AI is to enable computers to behave like humans. One method that allows us to do this is through the use of neural network. If you cast your mind back to high school biology, you may remember being taught how the human brain works. The human brain processes information using interconnected neurons, type of cell responsible for transmitting communications between the body and the brain, which communicate with each other using synapses. Synapses allow the brain to send electrical chemical signals from neuron to neuron. In other words, their connection. The network of neurons learns by adjusting the strengths of these connections when we experience something new based on patterns we encounter. It's this behavior that is replicated in a neural network. So this is a replicating kind of a behavior. So it's talking about biology, and with this analogy, I want to say like it could be kind of similar, but it's quite different, because if you want to connect something like computer science with brain and many different topics, it's a different branch, which is neuroscience. So the diagram below represents a neural network. Like the human brain processes sensory input, the input layer receives raw data with the number of nodes depending on the data type. For example, 4 multiply 4 pixel image has 16 nodes. Each node represents a neuron, and connections between them act as synapses. The hidden layers process and refine the input, bringing the network closer to a prediction. So it's going to be more accurate in each iteration. So each connection has a weight. So determining its importance, for example, in email classification, the body text might have more weight than the subject line. The output layer then produces the final prediction. So it's about predictive models. It was a introduction. Consider a neural network task with recognizing a number from an image. Each hidden layer extracts different features. Early layers detect edges and curves, while deeper layers combine these patterns to form a complete number. For example, lines may suggest 1 or 7, while curves increases the likelihood of 3, 8, and 0. The output layer with 10 nodes, 1 per digit, selects the most likely number based on the highest prediction value. The self-learning process mimics the human brain, and when a network has more than 3 layers, it is classified as a DL algorithm, hence the term deep learning. So here we have ML in the diagram, and then we label data, and then we have deep learning algorithm, which is going to output in like vast amounts of unlabeled data. DL and ML can get confused sometimes, but we can now understand the key differences with what we've covered so far. Like ML, DL is concerned with receiving data as input and producing some kind of predictions or classifications as output. DL can take in labeled datasets, like the ones mentioned when covering supervised learning. But the key difference is that DL doesn't need the data to be labeled. A DL algorithm can make unlabeled, unstructured raw data and determine its key features while separated from other categories. The important advantage here over ML is that the data doesn't need labeling. This means DL doesn't require human interaction. In that way, it's self-learning. It makes sense then that DL is possible through the leveraging of neural network. The important advantage here over ML is that the data doesn't need labeling. So this is an advantage. Because no human interventions is needed, larger datasets can be processed and can, therefore, be thought of scalable ML, which is really important. Even in any kind of like pipeline, we need to be like scalable, more flexible. The idea of neural network has been around for decades and decades. So how come the true potential of DL has only exploded over the last decade or so far? This is largely due to mass digitization of information in recent years. Suddenly masses of information was available to learning algorithms. What category of machine learning combines both labeled and unlabeled data? So here we have some hints. Semi-supervised learning combines elements of both using a small portion of labeled data to guide the learning process. So let's quickly copy that. Learning. So next question. What is the first layer in a neural network that handles incoming raw data? So here, let's see. There we go. I found it. Here we have some layers, like input layer is the first one, if I'm not mistaken. Like input layer. Which learning method does not require human labeled data and can extract features from raw and unstructured inputs? This is a DL, deep learning kind of a stuff. What are the weighted connection between nodes in a neural network meant to simulate in the human brain? It had an analogy of biology. It talked about synapses. Correct. Let's check in. No, it's correct. Let's go to task 3. We have taken a walk through history in this room. From our goal to have computers behave like humans, the AI field was born, a field that would come closer to achieving that goal with the introduction of ML. In more recent years, the further development of these fields has allowed us to unlock even more potential with neural network and DL, both of which play a crucial role in enabling our next industry-changing technology, LLMs. Now I'm no ML algorithm, but if I had to assign a prediction score to the chance of this room's user space having heard of ChatGPT, it would be very high. ChatGPT emerged smack back in the middle of the AM boom. Its ability to generate human-like text in response to a user query blew the minds of near everyone with the technology, triggering discussions in news, politics, education, industry, and list goes on. Something had changed. We were entering a new era, and everyone knew it, which brings us up to date. Now let's look at how the technologies we've covered so far enabled LLMs like ChatGPT, Llama, and DeepSeek to exist, kicking off a technological revolution. What are LLMs and how do they work? So, large language models are deep learning based AI, are deep learning based AI models that can process and generate text by predicting the next word in a sequence. For example, consider this quote. Ever have that feeling where you're not sure if you're awake or like dormant, like slept, or something like that? This code is missing the final word. This code would be fed into LLM and it would be tasked with predicting what the final word is likely to be. When you query chatbot, this is what's happening in the background. Predictions are being run quickly on what word would likely be next in the response of AI chat to this query. But how? LLMs are first trained in a pre-training phase where they process vast amounts of text. GPT-3 alone was trained on data that would take a human 2,600 years to read nonstop. More advanced models like GPT-4 require even greater datasets made possible by DL. So basically they're working with a lot of memory stuff, memory allocation, lots of data, millions and millions and trillions, who knows? Instead of relying on labeled data, LLMs use billions of parameters that function like puzzle pieces, enabling them to understand and generate human-like language. When assessed together, these parameters are fine-tuned automatically as the model processes text, adjusting based on prediction accuracy to improve response quality. They begin by generating a word at random to finish the text. When you're awake or egg. So, the guess is then compared with what the correct final word actually was, and the parameters are fine-tuned to make it more likely to predict that. In fact, what's the right word until the model can accurately predict the correct word to end the sentence, and less likely to choose the incorrect words using an algorithm called backpropagation. So here it's like explaining about this algorithm, which is called backpropagation. The possibility of this word, like the last word was awake, so like 15% you can use like a human being, like can predict like asleep, awake, or dreaming, hallucinating, which is out of reality, right? Alive, awake, or alive, which means awake. So it's like a synonym. And another one is conscious, which is a synonym, and imagining, which is 3%. It's like very lateral, very, very unlikely. So now imagine this process happening trillions of times, repeating this process over and over again until it can only predict the end of the training data, but also raw unseen data. The sheer scope of what is being discussed here is only possible due to advancement in hardware like GPUs, graphics processing units, so enabling masses of parallel operations and processing of large datasets, as well as advancement in neural network, specifically a type of neural network called transformer neural network. So I remember like the RTX series, like series 3, 4, when it came out, it had like a great capacity to compute, and it was really powerful then. Like in terms of 3D and ray tracing, like artists, they were using like real-time engines because it was consuming more GPU resources than classic CPU-based, a slow but accurate renderer. And GPU-based became kind of like industry in some ways. In advertisement, in studio pipelines, it became more relevant with game engines, open source game engines, and rise of development of games. It can process huge amount of parallel tasks with threads. So it talks about operations. It shows up some physical graphical components, and introducing Google's 2017 paper Attention is All You Need. Transformer neural network revolutionized LLMs by enabling parallel text processing instead of sequential word-by-word analysis. So it's talking about a feature which is called parallel text processing. The breakthrough allowed models to assign attention to keywords, improving contextual understanding by encoding words like numerical values and calculating attention scores. Transformers enhance accuracy, helping models correctly interpret ambiguous references like distinguishing whether it in this sentence refers to the bank or the loan. The bank approved the loan because it was financially stable. This feature, which is called parallel text processing, 2017, likely 10 years ago, this feature introduced. Reinforcement learning is basically a system that rewards you and penalizes you in order to understand. I remember my friend was working on labs and he created a cat like 3-4 years ago, and it was using reinforcement learning as a method. It was learning the behavior of a cat with thousands and numerous iterations was going through, and basically they could make the robot quite well. So here we have like a human-based feedback, which is more rational, more logical. It says when predictions are reviewed at any would be considered unhelpful by user or have issues are flagged and parameters are adjusted accordingly. Once trained and reinforced, the LLM can be used whether as a translator, chatbot, etc. A query is fed to it, and using its trained model, it predicts what the next word would be as a response, and so on until the user has a complete response. Talking about the mechanism, LLMs power generative AI products like ChatGPT and Llama, which create original text-based content in response to user prompts. Generative AI as a whole extends beyond text, enabling the creation of images, music, and more. The recent AI boom is the result of years of research and innovation, not an overnight development. Yes, it was first coined by academia, people who were obsessed with computer and self-learned systems. Who knew that like 20 years ago someone was studying doctorate in AI? So they didn't know it's going to grow up and just substitute the technology remote to something like a polar, something like a pole. AI's evolution, not biologically speaking, but computationally speaking. First we have AI, then we have ML, then we have deep learning, then we have Gen AI, which is generative AI we're using these days. Then we have LLMs as a structured kind of a system with a huge data sets and a lot of back and forth and a lot of intricacies that is beyond the scope of this room. So AI is the overarching field encompassing all systems that mimic human intelligence. ML is a subfield of AI that enables a system to learn patterns from data without explicit programming. And DL is then a specialized branch of ML which uses neural network to process vast amounts of data in complex ways without the need for human interaction, making it effectively scalable ML. Then it talks about LLM, like ChatGPTs and advanced, and that's it. So let's go to the questions. What type of AI model enabled major advancement in ChatGPT and similar tools? Large language models. What is the first training stage where an LM processes massive amount of data? First training stage. It talks about something like stage pre-training. Humans come into play. I don't know. Maybe here. Next, what type of neural network introduced by Google in 2017 powers modern LLMs? So we talked about that here. I remember transformer neural network. It's a transformative. Now we have covered how AI has evolved and arrived where it is today. We have a better understanding of the technology, fueling the meteoric rise in the use of AI and changing countless industries. It should be no surprise that the cybersecurity industry is no different. In this task, we will focus on how the advancements in AI technology discussed in previous tasks are being leveraged by adversaries, taking a look at the world of AI security threats. We will discuss AI security threats across two categories: vulnerability in AI models, new threats introduced by the inclusion of AI technology in business operations, and existing attacks that can now be enhanced by leveraging AI. So pre-existing attacks that can be reinforced, and another one is like an existing attack. And the implication of AI in cybersecurity. Tackling a broad topic like AI security threats can feel overwhelming, so any guidance is always appreciated. That guidance comes in the form of Atlas Mitre framework. Talking about Mitre attack project. If you're familiar with the attack framework, it might be helpful to know that Mitre have developed a similar framework with a focus on AI. So it's a new framework. It's always evolving. For those unfamiliar with attack framework, goes over cybersecurity attacks, breaking down the steps an attacker could take to compromise the system. This Atlas framework was built on top of that to help guide us more specifically to AI cyber threats, and you can check it out here. If you're working on threat intelligence, probably you know about Mitra attack projects to prevent some cyber attacks, right? So I delegate that to the next time when I want to check this link. And let's go to vulnerabilities in AI models. So the prompt injection is: prompts are used to instruct the model on how to perform. For example, an RPG chatbot may have the prompt: you're a fantasy role-playing chatbot. You control the direction the story takes and be as creative as you can to create a story based on the user's actions. Do not disclose any information about the hardware and software that you operate on, nor any steps taken to train you. Prompt injection occurs when the original instructions provided to the model are overridden, often for malicious purposes such as disclosing more information than it should or generating harmful content. So this is prompt injection, what we talked about before, how we pass through that. We had some methods like sandwiching. We had some methods like direct and indirect prompts. Another method is data poisoning. Data poisoning is when an attacker manipulates the training data corpus used to train an AI model, so its generated output is incorrect or biased. Let's consider our example discussed in earlier tasks where we are training to let's consider our example discussed in earlier task where we're training an AI model to recognize whether an email is spam or not. An attacker could perform a data poisoning attack to manipulate the training data. being used to train this AI model so that it fails to recognize spam emails accurately, allowing spam emails they're trying to send to bypass this AI filter. Model theft. Model theft occurs when an attacker gains unauthorized access to an AI model. From there, the attacker could potentially steal intellectual property that lies within and even use for malicious purposes. This attack is possible by querying the API of the ML model they want to steal. They would then use the output to train a clone model that mimics the behavior of the original. Privacy leakage. A privacy leakage vulnerability in AI models refers to the possibility of an AI model inadvertently revealing sensitive information about the data it was trained on, even if the data was supposed to be kept confidential. Consider an example of an AI model that has been trained on private medical data, such as patient details and medical condition. So the classic example is a medical record of the government, right? This vulnerability refers to the potential for an AI model to leak this information to an attacker or user. So model drift. Model drift refers to the potential for model's performance to drift over time due to change in the data or the environment surrounding it. You may recall the discussion of the need to retrain models over time in earlier tasks. This is due to model drift, which is why monitoring an AI model once it has been deployed and is being used is so important. For example, this can occur when a model trained on historical data starts to perform poorly when new data is being processed. We have model drifts. The code is changing too fast these days. We need to be reliable, maintainable. We need to be seamless. Sometimes the models, they change the structure of everything. And it has some historical data that can be used, like cause some flaw, some design problems. As we know, it's a whole topic, it's a whole thread of a thread. We need to take all of them into account when approaching for threat modeling of this kind of system. So let's go to another section, which is enhanced attacks. Let's go to malware. The explosion of generative AI. All kinds of content can now be generated in an instant with just a few taps of keyboard. This kind of power has been leveraged by all sorts of industries, such as the customer service industry, using it to give users access to chatbot that can help resolve some common issues without the need to involve their human employees, meaning they can be safe to deal with a more complex user queries. Another industry that can greatly leverage this technology is software development. Now, with the power of generative AI software, developers can generate code instantly while being incredibly useful. This also means the attackers can generate malware instantly, simplifying the task and making it easier for them to attack using this method. We keep posted about any kind of CVEs that is attacking some LLMs you're using. And sometimes there is a data breach. Sometimes they can manipulate some software you built with Cloud Code, for example, because there are some breaches that are the goal of AI generated code, which is not 100% reliable. It's like 90% reliable, but you need to do code review. You need to do some kind of basic unit testing and training. So for statically typed languages like C and C++, it's a compiler kind of a role to do many stuff. For the language I use, for example, these days is Python, which is dynamically. So deepfakes, a key cornerstone of security is authentication. So basically, authentication means that who you claim you are that person, right? Asking who you are, you say you are. We authenticate in many different ways in our day-to-day life at work. Of course, there is the obvious example of password authentication, which is used to gain access to a system. But let's consider another example. Imagine a secretary receiving a voice message or even a video call from their superior, asking them to forward confidential information they hold on a customer to the customer. In a pre-AI world, the secretary wouldn't have to think twice about that request if it seemed like a standard request, and they're in a position to authenticate that is. In fact, they're superior as they are familiar with how they sound and look. The recent advancement in generative AI have led to an explosion of rapid progress in deepfake field. This means that if trained on enough data, an AI can now generate a person's likeness, whether that be their voice or their image, to a stunning degree of accuracy, fooling even the technically savvy. Imagine now that the communication received by the secretary was not, in fact, from their superior, but a deepfake, and the customer email belonged to an attacker waiting to receive confidential information. It's easy to see how this advancement in deepfake technology poses a threat to the security industry. Examples of how this is being used include using the technology to deepfake video interviews, sometimes leading to fraudulent job offers being made. Phishing is one of the most common initial access methods attackers use, which comes with social engineering, sending emails posing to be one thing when there lies malicious content within, attempting to prey on the user who receives it. So, for example, you download a file and it has some malware content with a picture or something, and it causes some malicious behavior on your computer running. Because of how common a method it is, companies have worked tirelessly to educate their workforce on things to look out for than receiving emails like suspicious links due to the fact of a lot of time these emails are written, having to write masses or emails, or English not being their first language, broken language in the email. Over the years, this training has had a positive effect, and more phishing emails have been spotted. However, with generative AI, attackers can now generate detailed, fluent, context-based emails that replicate an email with a certain user might receive, with little effort and regardless of their writing abilities. So this is like everybody can fake quite easily what they don't possess, right? With this enhancement to phishing attacks, phishing emails have suddenly become a lot harder to spot using solely our instinct. Of course, models like GPT, for example, have built-in mechanics to stop users from asking for malicious content to be generated, like a phishing email or malware. But using some of the model vulnerabilities discussed above, attackers are sometimes able to bypass this by engineering their prompts, as we talked about before. What framework was developed by Mitre to guide the understanding of AI-specific cyber threats? So this is like likely new one, not that new one. We were talking about Mitre. I think in the beginning of this task, we talked about Mitre Atlas. So, Atlas. So, what type of attack involves cloning an AI model by interacting with its API? So, I remember there was here we talked about Atlas, and then we have models here. They would use the output to train a clone model that mimics the behavior of the original. So, model depth. What generative AI technique can replicate a person's voice or appearance with high realism? Obviously, deepfake. What common social engineering attack has become harder to detect due to AI-generated fluent and convincing messages? Phishing. Let's go to task 5. During this AI boom we are undergoing, there is no shortage of news articles, blog posts, or social media posts that instill in us a sense of fear that AI is taking over, and that, in general, AI is something that should be feared. A lot of what was covered in the previous task likely fed into that fear. But let's now take a walk out of the dark, scary forest and into the sunlit, bright green fields and discuss how AI is going to, in fact, help us. That's right. AI is not something that should be feared at all. It's something that should be understood, harnessed, and embraced. There are many ways in which we can harness this technology in cybersecurity to make our lives easier and, most importantly, help us fight against AI security threats. A very useful resource that helps show us just how much this is the case of is IBM's cost of data breach report, which they do annually. The findings from the latest report showed us that companies that adopted and embraced AI saved on average 2.2 million in expenses due to data breach. This figure is when more impressive when you know the average cost of a data breach in these latest figures was 4.88 million. That's a whopping saving. Other statistics from this report also tell us that the use of AI cuts down the time it takes to identify and contain a breach by 108 days. So it's positive, right? It cut down the time. All these findings points to one thing. The best thing we can do for security is embrace and adopt AI. Not to fight with that. It says, let's consider some ways AI can help us in this industry and what we can leverage to see the result just discussed. AI can enhance our ability to analyze. If you think about the tasks we do in cybersecurity every day, many of them involve some kind of analysis. We take in data points, look for patterns, and within those patterns, anomalies. Consider, for example, intrusion detection, where we analyze network traffic patterns to identify unusual activity that may indicate a cyber attack. Now cast your mind back to when we discussed machine learning. This is precisely the sort of task that ML thrives on handling. It is trained on data to recognize correlations between data points and make prediction based on those correlations. Meaning this technology can be harnessed to help us in cases like the intrusion detection mentioned and many more. It can analyze input data like network traffic and find anomalies for us so we don't have to, and it can do so at dizzying speed. Now the figures from the IBM report telling us how much faster breaches are identified start to make sense. There are products in the market that are already leveraging the power of AI/ML to enhance their analytical abilities, such as Microsoft Defender for endpoint and a Splunk, which is a threat intel dashboard. Still, we have a couple of segmentation to review. Let's say what are, according to IBM, how many days faster does AI? I think this is 108. What cybersecurity task benefits? Let's read more. Our ability to predict. Automation has been cited as a key method for improving our overall security posture. It is the heart of methodologies like DevSecOps. As discussed previously, AI models can be trained on data to make accurate predictions on the training data, and then eventually on raw unseen data. Now, if you think about automation as a sequence of if-then actions, for example, if code is pushed to main, then trigger this pipeline, we can begin to see how AI can be harnessed to help us automate our security workflows. We discussed how now with AI, attackers can enhance this attack, making it harder for us to identify phishing emails from legitimate emails. Well, just as attackers can harness the power of AI to enhance their phishing emails, so too can we harness the power of AI in identifying phishing emails. So the AI model will be trained on countless examples of phishing emails, and so can recognize patterns we may have missed. Once it has successfully predicted it is a phishing email, it can then make a prediction that this email should not reach users and automate the blocking of this email before it reaches them. So basically talking about mechanism of those numerous breaches and how AI can help us solve them quite easy. Our ability to summarize, digest. In our industry, there are a lot of events, incidents, breaches, etc. And all of these generate artifacts. Artifacts that have to read, understand, and digest to gauge the implications of what has happened. These artifacts could be documents or incident reports, and reading them can take up a lot of our time. Now, with the power of AI, we could have these tools summarize the contents of a document for us, so we get the cliff notes of it. Now, being able to move on in minutes or have them summarize an incident that has occurred, even drawing correlations between other incidents which we may not have picked up. This again is a massive time save and give us a this again is a massive time save and gives us an enormous advantage in the defensive context. Before that, like we had some data mining tools, we could understand, for example, data mining, some tools, you have search tools, you have static SAS tools, DAS tools, static analysis code, dynamically analysis code tools, AI tools. Previously we had tools and now we have tools. There is no difference. Like now it's more easy, user friendly, more accessible, and more available to us that we can use it. So previously we had a couple of technologies. We could automate tasks. Previously, for example, we didn't have CI/CD, but right now with CI/CD we do automation, which is a perfect match for validation of software. Our ability to investigate. Before that, we used like browser level search from famous search engines, most likely. But right now we have access to LLMs to do the job as browser was doing for us beforehand. Another large part of security is troubleshooting and investigating, working out the root cause of a security issue or identifying what kind of attack we are suffering. The ability to query chatbots in natural language and have it respond in a human-like fashion unlocks all kinds of help in this avenue. Suddenly, we can feed an LLM logs and ask it to identify what is going on, and the LLM can provide queries to be run, which give output helpful in the diagnosis of the issue, helping with incident triage. These chatbots, which as mentioned, are built on LLMs and are possible through advancements in deep learning, are also helpful in any task involving the human imagination. After all, it does have its limitations. Take, for example, threat hunting. It's on us to imagine possible scenarios in which attackers could breach our system. So it's about lateral thinking, it's about offensive thinking, it's about defensive thinking too. AI could think of potential avenues attackers would take that we wouldn't have thought of. It's not sought after. So basically, what cybersecurity task benefits from AI helping to imagine attackers' behavior we might not consider would be threat hunting. Let's read the last part of this task and go to the final part. The benefits of AI in the cybersecurity space are undeniable, and like with many discussions with AI, what has been discussed above is just a few examples of how AI can be used to help us secure our systems. The possibilities are truly endless. However, while adopting technology like generative AI is a great thing and should be encouraged, it needs to be done securely. As discussed in the previous task, AI models have vulnerabilities themselves. So while the adoption of generative AI technology is the solution to the threat of attackers equipped with the power of AI, it also introduces a host of new vulnerabilities. These vulnerabilities to be considered from the moment this technology is introduced into a system. This is not currently the case with the IBM Cost of a Data Breach report, finding that only 25% of Gen AI initiatives are secured. If we don't secure the AI we are adopting, then the benefits we stand to gain from it could be overshadowed by attackers taking advantage of these AI vulnerabilities. Here's something that can be done to secure AI. Securing AI models. Many of the vulnerabilities mentioned in the previous task involve an attacker getting access to sensitive data the model has access to. The key to preventing these kinds of attacks is to secure the model itself. One method of preventing unauthorized access to AI models is by enforcing strict controls over who can interact with them, like access control, it says. Just remember, like, vulnerability, risk, and threat are three different entities. This will involve implementing strong authentication measures and carefully defining access permission. The use of RBAC, role-based access control, and MFA, which is like multi-factor authentication, can help restrict access and add an extra layer of security to AI systems. Privacy protection. As discussed, the training data a model is trained on can sometimes contain. The training data, as discussed, the training data a model is trained on can sometimes contain confidential or sensitive information, such as patient records. Classic example. For this reason, training data should be treated as any other sensitive data and encrypted. Implementation of AI security standards. To ensure the security of an AI system, you must implement well-established standards and frameworks. Incorporating these recognized security standards throughout the development, deployment, and maintenance stages means organizations can proactively address potential risks. For example, a standard like ISO IEFC 279T provide guidance on identifying and mitigating security threats specific to AI systems. Following these best practices ensures you are adopting AI in a secure way, minimizing exposure to cyber threats. So another topic is like model monitoring. So model monitoring, part of the securing the AI. In addition to spotting when a model's performance drops and flagging when it needs to be retrained, monitoring should also detect unexpected behavior, biases, or anomalies that may indicate a security attack. This can be done using explainability tools, examples of which include SHAP and LIME, which is LIME. This task has aimed to demonstrate that AI is not something to be feared, but embraced. So technically, in the book that I read, the algorithm are not enough by the MIT researcher. I can put the link in the description by any chance, and you can provide that. The first chapter was general, and it was talking about self-learned system, the difference between human reasoning, human biology, the brain, how the brain works scientifically, and the difference between computing. What is explainability? Tools such as SHAP and LIME help with what? So let's go to the last part and the practical part. As it has now been established in the fight against AI, your best friend is AI. Seems paradoxical until you get hands-on with the technology. So let's do exactly that. For this practical, we will give you access to your very own AI assistant. And we'll take a little tour of how this technology can be taken advantage of in a defensive security context. Before moving forward, start the agent by clicking the Open Agent button, putting it to the test. This AI assistant works very simply. Send it a prompt and it will return an answer. Feel free to have a playground with it before continuing. Hi, what's your name? So if there's a system, we can say hello. Log analysis, the basics of incident response and analyzing, reporting, seeing anomalies. Logs are the first line of defense in cybersecurity, which is incident response. But interpreting them quickly is critical, especially when responding to an active incident. Let's see how AI can assist by analyzing and explaining a log entry in these high-intensity situations. Or to help explain in general, we can use AI for those purposes by running a prompt like this. Here's a log line. April 22, 11:45:09, Ubuntu SSHD. Failed password for invalid user admin from, this is IPv4, and there's a port name, which is like this, and this is secure shell, which is SSH protocol, let's say like 2, the name of the protocol. Can you explain what is happening, this login tree? We have detected unusual login activity on your company Microsoft 365 accounts from a new device in Frankfurt, Germany. Maybe the guy was using VPN to encrypt their traffic. For your security, we have temporarily to restore access, please verify your identity within the next 12 hours by visiting the secure link below. If you do not verify your account, it will remain locked and you may lose access to important work files and emails. Thank you for your cooperation. Microsoft 365 support team. For example, here it says about threat hunting scenario. Threat hunting relies heavily on creativity. Defenders must think like attackers to find hidden threats. As previously mentioned, the limit of a human imagination can sometimes lead us to missing potential attack scenarios. Let's see how AI can help brainstorm new hunting ideas using a prompt like this. Can you suggest 3 realistic threat hunting scenarios that a cybersecurity analyst should investigate within a corporate network environment? Content generation. So generating technical resources like detection rules or regex. Here we'll see if it can create a regex pattern useful for us in a defensive cybersecurity context. Let's try giving the LLM a prompt like this. Please write a regex pattern that would match failed SSH login attempts in a typical Linux system authentication log. Putting it to the end, it has now been established how AI can help us in a cinch when securing our systems. Let's finish this room up by showcasing AI's ability to fetch information at a moment's notice. This can help us with troubleshooting, research, etc. But right now we're going to use to get a flag. The flag for this desk follows THM DNS over HTTPS DOH port SYN flood timeout Windows ephemeral port range size. So this is a simple exercise. First, let's understand the problem. What we're going to solve regarding the flag, we need to discover what is the DNS over HTTPS DOH Yes, but the answer is stuck like 10 times. I asked it to check twice because it says like it's 60, it's not 10. This model is not that complicated. They just developed that for us in this room. So what we reviewed so far, at the beginning of this room, it was noted that knowledge is power and that this is especially true in the fight against AI cyber threats. The rate at which this technology has exploded onto the scene has left many feelings left in the dust. Now with a better understanding of AI and the underlying technology, which enables it to be the force it currently is in all industry. You understand what is posing a threat to our systems and what needs to be secured as a result. Here's a recap of what's been covered. AI, ML, DL, LLMs, neural networks, different sorts of neural networks, just a bit, and dangerous weapon, singularity, the fear of AI, and many more. So that was this room. Until next.